Greetings, detectives. Mrs. McKay here, and we are working on Case 6, Solving Systems of Equations, and we're going to learn one new way called elimination. It's also called linear combination in your book, but I call it elimination. So our learning target clue 6.3 is I can graph a system of equations by elimination. So make sure you have that written down. Now this is going to be the short version, so I'm going to talk really fast. If you want a slow and very careful explanation, you should watch the longer version. Okay, it's about 30 minutes long. This one's only going to be 15. So let's review what we know. We know that we can solve systems by graphing, where we graph two equations, look for where they intersect, find that point. The x and y of that point are the values that make that a true statement. We also know that we can solve using substitution, and when that happens, we get one variable by itself, say like this, x equals 2y plus 1, and in another equation, we substitute whatever the x is, 2y plus 1, in place of the x of the other value. So let's say it was 3x minus y equals 7. Then we could put the 2y plus 1 in place of the x, solve for the y, go back, solve for the x. So that's another video. I just want you to remember that. Now I've written out all of the steps on the side here that you can use later, but I'm not going to walk through them now. I'm just going to solve the equation so that you can see how I'm using those steps. The first thing and the most important thing to realize about the goal of elimination is you want to eliminate or get rid of a variable. So go ahead and write that down. That's the goal. We want to eliminate a variable. So the way that we do that is we actually use, and this is why our book calls it linear combination, we actually add the two equations together. We add the two equations together, and when we add them together, our hope or our goal is to get rid of, like a magician, make one of the variables disappear, so that now all that we have to do is solve for one of the variables. Once we've solved for one variable, we go back, we solve for the other variable. All right? So let's start with this one. Here we have negative 3x plus 4y equals 12. 3x minus 6y equals 18. Now if I added this system, if I added these two together, what would happen to my x variable? Well, I would add negative 3x plus a positive 3x, and it would disappear. It would become 0. So that's one of the things that I look for, is I look for, are there any variables that when I add them together, they'll disappear? If that's the case, then I can easily use elimination. So let me show you what I mean. I'm going to add, they have to make sure they're all lined up. My x's are lined up with my y's, and I'm going to add them together. Negative 3x plus 3x is equal to 0. 4y plus a negative 6y is negative 2y. And 12 plus 18 is 30. Now, I have negative 2y equals 30, so I divide by negative 2, and I get y equals negative 15. Well, now I know what my y is. My y is negative 15. Okay? So, now I just have to figure out what x is. And the way that I figure out what x is the same way I did it with substitution. I take the negative 15 for y, I plug it in one of the equations for y, and I find out what the x is. So why don't you go ahead and do that. Take the negative 15, choose one of these equations, plug it in for y, and solve for x. Okay, so did you do it? I chose the first equation just because I think it's easier to multiply 4 times 15 instead of 6 times 15, but either way works. And so I plugged in the negative 15 and I multiplied things out. I solved for x and I came up with x equals negative 24. So now I have my solution. The place where my two lines intersect, the x and the y that they have in common is x is negative 24. Y is negative 15. And I could go in and double check by making sure that it makes it a true statement in my second equation as well. 3 times negative 24 is a negative 72, and negative 6 times a negative 15 is a positive 90. So positive 90 minus 72 is 18. Feel free to use a calculator or do it on your own, or just trust me. But you should never trust me because I make mistakes all the time. All right, here's another one. This one is written 4x minus y equals 12. I'm going to just draw a line here so we can see the difference. 4x minus y equals 12, and y equals 14x plus 18. Again, I want to try to add these together, but the problem is that I can't really add a 4x and a y, or a negative y and a 14x. I need to make sure that both equations are in the same format. This first one's in standard form, and the second one's in slope-intercept form. So I want to make sure that I get them in the exact same format. So I'm going to go ahead and subtract 14x from both sides so that I can put my my x underneath an x, my y underneath a y, my constant underneath a constant. I'm going to rewrite it over here. (4x minus y equals 12), and now I have 14x plus y equals 18. See how I did that? All I did was just switch it to standard form. Now I'm going to add them together. I get 10x. Negative y plus a positive y is 0. So again, I've eliminated my variable because that's my goal. I want to get rid of a variable. Equals 30. Divide by 10. Actually negative 10, because this is a 4x minus 14x, or plus a negative 14x, is negative 10x. Divide by negative 10, and I get x equals negative 3. Here's my x and my y. So now you go ahead and use your negative 3 for x. Plug it into one of these variables, whichever one, or one of these equations, whichever one you like, because we're going to do both of them anyway, and see if you can figure out what y is. Okay, did you come up with negative 24 as your value for y? That's what I came up with. I went ahead and chose my first equation, 4x minus y equals 12, and I put negative 3 in place, and you can see all of my work here. You can pause it and look at my work, make sure that I did it right, but eventually I came out with y equals negative 24. I can double check it by going back to my second equation and seeing if negative 3 for x and negative 24 for y makes the second equation a true statement, because that's my whole goal. I'm trying to find the x and y that they have in common. So when I put negative 24 in for y, I end up with negative 24. I'll just write it right here. Negative 24 equals 14 times negative 3. So 14 times negative 3 would be 28, and another 14 would be, let's see, what did I just say? 14 times 3 is 12, would be 42. And that's 14 times negative 3, so that would be negative 42 plus 18. When I add negative 42 and 18 together, I get negative 24. And so the second one works as well. So my solution to this system of equations is negative 3, negative 24. Now sometimes it's not so perfect. It doesn't work out that I can just easily, even by rearranging, that I can easily just add and have my equations work out so that one of my variables gets eliminated. So let's take a look at this one. And even though this says solve using elimination, I want you to think about this as solve by multiplying by negative 1, because that's what I think subtraction is, okay? I always like to add instead of subtract, so I always think that subtraction is adding the opposite. So now, let's look at this equation right here. 4x plus 2y equals 28, and 4x plus 3y equals 18. So this system has two equations, And I notice that I'm close to being able to add and get one of them to disappear. You might think that the 2y and the 3y, oh, if you add them, that's just a y. But I didn't really eliminate the y, did I? It's still there. It's a 1y. But this 4x and 4x, if one of those 4x's was a negative 4x, then I could add them together and they would become 0 because that's my goal. I want to eliminate one of them. So I'm thinking this 4x and this 4x, if one of those became a negative 4x, I could then add 4x and negative 4x and make them be 0. But how do I turn one variable into a negative? How do I make 4x become negative 4x? What should I do? Well, I should multiply it by negative 1, right? But I have to remember that if I'm going to multiply by negative 1, so I'm going to go ahead and multiply this top one by negative 1. If I'm going to multiply by negative 1, then I have to make sure that I multiply everything by negative 1. I can't just multiply the 4x. I have to multiply the 2y, and I have to multiply the 28. So I'm going to multiply everything by negative 1, and I end up with, I think I'll use a different color, negative 4x plus a negative 2y equals negative 28. See that? So all I did was I multiplied everything by negative 1 so that I could turn one of my variables into a negative. Now I can add these together. Negative 4x and 4x is 0. Negative 2y and 3y is positive y. And negative 28 and 18 is a negative 10. So my y is equal to negative 10. And I just need to now find my x. So you go ahead and find the x because you now know that y is negative 10. Go ahead and find the x. Okay, I did my work right here. I plugged in negative 10 for y and I solved for x and I came up with x equals 12. So 12, negative 10, my x is 12, my y is negative 10, is the solution to this system of equations. I used this first equation to figure out what my x was, but I could have used the second one, and I always like to double check and make sure that it works in the second equation as well. So 4 times 12 is 48, and 3 times negative 10 is negative 30. 48 plus negative 30 is 18. And that's what it should be equal to. 18 equals 18. So it worked out. All right, we have one last one that I'm going to have you work on now. I want you to take a look at it. We have x equals negative 3y plus 7, x equals 6y plus 16. Now, if it were me, I would probably use substitution in this situation because I have two x's by themselves. But for the sake of learning elimination and being able to change one equation or one variable so that it has a negative coefficient, let's go ahead and do this. So pick one of these equations and multiply it by negative 1. Why don't you go ahead and do this one? You could do the other one if you wanted, because we're going to try to eliminate these x's because we have a x here and an x here with a 1 in front, but if we add them together, we'll get 2x. We want to add them together and get 0x. Looking at the y's, it would be really hard to eliminate the y's at this point because they're not the same coefficient. They may be opposites, but I'm not going to get the same, I'm not going to get 0 when I add them together. So go ahead and multiply negative 1 times x equals 6y plus 16 and rewrite your equation over here. Rewrite your system right there. Now that you have your system written, you should have negative x equals negative 6y plus negative 16 on the bottom. Add your two together and eliminate your x's. Now it's time to solve for y. You're going to need to get your y isolated, so go ahead and solve for y and see what you get. Now that you know what y is, go ahead and figure out what x is. And our solution is x equals 10 and y equals negative 1. The point is 10, negative 1. Where the two lines cross. And that's it. Remember, I have everything written up here for the steps to solving the equation, or systems of equations by elimination. You need to write yourself a key idea. I have a little remember you have to multiply by negative 1 to be able to get your coefficients totally